Hi guys, how are we doing? My name's Andy Shepherd. I just wanted to talk to you a little bit today about some Azure networking information that I think might be useful to you all. So from my perspective, I'm an infrastructure engineer typically, and I've very recently taken it upon myself to look into the AZ700 exam just to try and complement some of that infrastructure knowledge that I've picked up over the years. In the Azure world, as you know, it's mostly software-defined networking, so the sort of relationship between infrastructure and networking is a little bit more blurred. You kind of need to understand both to be able to have a good grasp on how things fit together in Azure. So yeah, the AZ700 exam felt like a good place to start for me. I managed to pass that successfully a couple of weeks ago, so I thought it'd be nice just to go through some of the things I learned from that. So that's what we're going to do today. So there's a number of different aspects to Azure networking services, so you can see some of these on the screen there. I'm not going to do all of these today, but I'm going to pick some from each of these categories just to talk a little bit about what I see as the fundamentals, really, the sort of the starting point that most people are going to think about when they start to look at an Azure migration, and certainly delivering services from Azure as well, and adding some layers of protection to each of those different things. So we're going to touch a little bit on virtual networks. We're going to touch a little bit on the protection of those virtual networks within Azure, so using things like network security groups and Azure Firewall. We're also going to look at some delivery concepts. So front door, traffic manager, application gateway, and load balancer are the primary options you've got for delivering services from Azure. So we're going to look at those, and we're going to look at how those kind of interconnect and how you might use combinations of those to be able to deliver services. And then we're going to look at some on-premise connectivity as well. So using things like VPN, site VPNs, and ExpressRoutes as well. So we'll crack on. So what I see as kind of priority number one, really, when you start to look at Azure services is how do my networks fit together? What kind of network arrangement do I need to create in Azure to be able to connect my services and deploy my services into those networks? So, I mean, it's kind of similar to what you would have on premise, really. You need to define a network range that you need that you can use as a VNet within Azure. What we typically suggest really is that you go with a reasonably large network range, so starting off with a /16, for example, and assigning that to a VNet. And you can see on the screenshot there, we've then got some /24 subnets within that, which you'd use to break down the environment and deploy services into. You might have more than one network as well. So you might have a couple of /16s in Azure. For example, if you have the sort of enterprise scale landing zone deployment, you'd have a hub network, which would be a /16, and then an identity network and a production network, which would house your services. And each of those will be a /16 if possible. A lot of people do struggle with allocating such large ranges to Azure, so it might be that you need to use a smaller range than that, which is totally fine as long as you've got the capacity to break that down into separate subnets within that to be able to deploy services into, as you can sort of see on the screenshot there. But the key concept is making sure you've got large networks defined as your VNets, and then subnets within those to deploy your services within. Once you've got your networks in Azure, you may want to connect services that reside in different networks together. And the way that Azure allows you to do that is to use VNet peering. And what essentially you're doing there is connecting two of your networks and allowing the traffic to flow between those networks within Azure using the Azure backbone network. So you don't actually have to, there's no physical network patching involved or anything like that. It's just a case of allowing connectivity from one VNet to another. And when you create those peerings, it also creates all the routing that's required for that as well. And you have a couple of different options to select as you're creating that peer link as well. You can see on the right hand side there, you've got the option to allow or deny traffic from the remote network. You've got the option to allow or deny traffic to the remote network. And you can also use services that exist in one network from the other network, such as the virtual network gateway, which you can see there. So if you had a VPN or an ExpressRoute terminating in your hub network, for example, you wouldn't necessarily want a new VPN gateway and a new hub network in every network that was peered. You would use the hub networks VPN gateway or ExpressRoute gateway for that, and you can use that option there to ensure that that's configured as you need to. You need to configure both sides of the peering as well. So you set up the source network peering, and then you set the destination network peering up at the same time to allow that connectivity to work as expected. Once you've got your networks in Azure, it's a really good idea to use some security on those to make sure that you're only allowing the traffic that you need or that you should allow across those networks. And network security groups is kind of the entry-level way of doing that, really. It is basically a localized firewall for your VNet or subnet. You could apply those at a couple of different levels so that the subnets themselves can have a network security group associated with them. The NICs of specific virtual machines can also have specific network security groups attached to them, but most people tend to go with the subnet approach because that gives you a little bit more flexibility and it's easier to manage as well on an ongoing basis. There's less NSGs to manipulate and make sure that are set up correctly. You can also hook those into the concept of an application security group, which is more of a logical concept than actually allowing any functionality. But what that does is it allows you to specify particular virtual machines within a network security that are connected to a subnet that has a network security group attached to it that serve a particular purpose. So, for example, if you had a bunch of domain controllers that were sat in a subnet, you would use an application security group to attach the Active Directory rules to allow those servers to function as you need them to. You wouldn't necessarily need those same rules to be applied to a standard member server in the environment. So you would use an application group to separate those things out. Even though they're in the same subnet and they have the same NSG attached to that subnet, you can then granularly assign those permissions from a network perspective using those application security groups. So just a bit of an example here on what an NTier architecture might look like in Azure. So if you think of this as just a standard sort of web service deployment that you've got on premise, so you have a couple of different tiers to that. You've got the web tier, which would typically sit in the likes of a DMZ network, so it'd be available across the internet. And you'd have an application tier, which would do some of the functional processing of the application once users are connected to that. And you might have a backend data tier, which would store storage information. Any kind of database connectivity that's required will all be handled in that data tier. And obviously, if you had this built in Azure, you wouldn't necessarily want to expose the application tier or the data tier to those end users that are coming in on the external IP address at that web tier top end. So what you would do is you'd use an NSG to allow connectivity to the app tier from the web tier IP address only, so that 10.0.1.18 IP address. And similarly with the data tier, you wouldn't want end users connecting to the data tier at all. So you'd use that internal IP address of the application tier 10.1.1.32 and allow that to connect to the data tier, and that will be the only method of connecting into that from an application functionality perspective. You still allow management ports and things like that you need to be able to manage the machine on a daily basis, but from a sort of functional point of view, from the application's perspective, then you'd make sure that only those specific IP addresses were allowed through that NSG to be able to connect. Just a little bit about Azure Firewall as well. So once you first start deploying to Azure, it might not be required to use Azure Firewall, but once you start to use things like the internet breakout services within Azure, and actually allowing network connectivity from your internal network out to the internet from Azure, then you probably need to use an Azure Firewall to sort of sit behind that, similar to what you would on premise, really. You wouldn't necessarily just want people to be able to browse the internet without any kind of restrictions in place, or at least some login information to see what they're doing, and making sure they're not susceptible to any malicious activity on the internet as well. So Azure Firewall is a good way of doing that, real simple to deploy. It's obviously compatible with most of the Azure functionality, such as log analytics and being able to actually save information in Azure and analyze that to understand exactly what's going on. And it operates with a deny by default approach, so similar to what you would with an on-premise firewall, really, where you can't access the internet unless you allow those services through that firewall. Similarly with the spoke networks, you can see there in this particular diagram, the firewall is sitting in a central VNet, and any connectivity in and out of that VNet would have to be allowed via that firewall in this approach. So I'm just going to real quickly jump into the Azure Portal just to have a look at some of those things, just very quickly, just to show you what those look like. So I'm going to start with some virtual networks. So if I have a quick look in my setup here, this is a MSDN subscription. So it's just development information here. There's nothing sensitive. It's not a fully production environment, so I can only go so far with demos, but hopefully you'll get the idea of exactly what we're looking at here. So in this case, I've got a couple of networks created. I've got a hub and a production network. If I look at the hub network, you can see this has been given a /16, and if I look at the prod network as well, you can see that's also got a /16. And if I look at the hub network, I've got a couple of subnets in there, just a gateway subnet in there, which is being assigned. So a gateway subnet would house either an ExpressRoute or a VPN gateway. In this case, I've just got a VPN gateway sat in there. It's not doing anything, but it's sat there ready to use. And then the production network, the subnets, I've got an app, a web, and a data tier. So similar to the diagram we've just seen, really. And at the moment, we don't have anything connected to either of those environments, and they're not peered. If you look at the overview, you can see the peering section there is not connected. But if we look at the peering section, we can actually see if we can add one. So these are the types of information that you get. There's those 3 questions. Do I want to allow traffic from the remote network? Do I want to allow traffic to the remote network? And is there a network gateway that we can use at either side of that peer to make sure that the connectivity back to on-premise is going to work? So I'm just going to call this hub to prod. And I'm going to say we're going to use this network's network gateway. And the reverse of that would be prod to hub. So it actually allows you to set up both sides of the network, both sides of the peering, sorry, at the same time. So the remote network is the production network, and I'm going to use the remote. So from the production network, it will be classed as the remote networks gateway, and from the hub network, it's classed as use this networks gateway. So it's important you get those settings the right way around, otherwise the connectivity is not going to work. I click on add, and that's it. That's the peering created. It usually takes a couple of minutes to revert to a connected state, but once you've done that, you can then allow traffic from the production network into the hub network, and it will also, if you had an active VPN gateway as well, it will be allowed to traverse that gateway from the production network back to on-premise if you needed it to. Just very quickly, also want to touch on the network security groups. So I have a network security group set up. And show you very quickly. So you can see here, this is just a test VM NSG, so it doesn't particularly do anything. When you first create an NSG, it has these routes built into it, or these rules built into it, I should say. And these are there by default. You don't have to create those, and you can't remove them either. And they're there to allow interconnectivity between specific Azure services. So what it's allowing in this case is virtual network traffic. So any traffic on that same virtual network will be allowed. Azure load balancers, which is obviously a service that exists within Azure, you need to allow that through an NSG to be able to allow that to connect. And that's there just to make sure those services actually work properly when you do enable those and use NSGs as well. And then there's the deny all rule as well. So you can only get so far inbound before it will deny any traffic coming through. Similarly outbound as well. So worth noting that all services by default in Azure can access the internet. So if you build a virtual machine, for example, even if you drop it into this default NSG, you would still be able to browse the internet from that virtual machine. So that's what I was saying about the Azure Firewall, really, and that once you start having additional virtual machines in there, more and more workloads, they are going to be able to browse the internet by default, unless you change that or block that with a higher priority rule, for example. So you might want to look at Azure Firewall to kind of bring that down and try and make sure that everything is protected from those NSG rules. We'll just have a very quick look at Azure Firewall as well. So nothing too startling with that one. If I go to create firewall, so there's sort of a couple of concepts to think about with the firewall, really. So you've got the firewall device itself, and then you've got the rule policy base that sits on top of that. So I'm just using some of the default resource groups and things like that I've got. I'm not going to use availability zones in this case. I don't have, if I select use existing, so I do have a policy, so I can select a policy, but I also have some virtual networks created, which you saw, but you can see I can't select those because they actually exist in UK and West. So in this case, if I flick that to UK and West, I should now have the ability to select my hub and prod network that we've just seen. Now, in this case, I would obviously drop it into the production network, but it's actually looking for a very specific subnet in there called the Azure Firewall subnet. Similar to a VPN gateway, that has to be deployed into a gateway subnet. With Azure Firewall, this has to be deployed into an Azure Firewall subnet, and it has to be named exactly as it is there. In this case, I don't have one, so I can't create this, but you can see I've got a test policy there You would typically give your firewall a public IP address as well. Again, I've got a test public IP address there that I could use. I'm not going to create it at this time because I don't have the subnet available, but it's literally a case of filling in these values and click on review and create, and off it goes. And we'll just have a quick look at the policy as well. So if you go to the firewall policy section, you can see what those look like. And if it's very, very similar to an on-premise firewall, same sort of concepts. You could do things like NATing. So if you want to hide on-premise, Azure-based servers behind a public IP address of the firewall, then you'd use a DNAT rule to do that. It has the concept of rule collections as well. So you can group a series of rules together for a particular application or a particular function within Azure in a rule collection and give that whole rule collection a priority. You see I've got 200 there, and I've got another collection group here with a priority of 100. So what it will do is it will look at the rule collection group first, and this is a priority 100, so this will be processed first. It will then process all the rules again in priority order within that collection group, and then it would move on to the next priority collection group. So in this case, I've got a 200 priority collection group, which is allowing HTTP traffic in. I'll have a quick look at that rule just so you can see what that looks like. Fairly straightforward. We're allowing port 443 inbound to a particular range within the network. There is also the concept of, so that was a network rule that we've got there. There is a concept of application rules as well. So this is specific to HTTP, HTTPS, and SQL. So it's usually used to sort of protect those sort of internal communications for that type of thing. And it's very specific to those things. And you can use things like tagging and all sorts of stuff to create your rules when associated with those. Okay, so let's just jump back to the slides real quick. So I wanted to talk a little bit about some of the delivery options you've got within Azure as well. So obviously one of the sort of first things you'll evaluate when you're starting to move to Azure is how to take some of those things like load balancing that you would do internally. How would you do that in Azure? What type of services are available to you to be able to present those applications to the internet if need be, or even just internally? What kind of load balancing options, what kind of traffic management facilities are available to you? And there's a couple of, well, there's four really that I want to talk about today. We're going to kick off with, we're looking at the Azure Application Gateway. So this is the HTTP specific Azure Application Gateway process. It's layer 7. And you can see in the diagram there, it uses URL-based transport rules. So you can decide based on the URL of the incoming connection on which server pool you'd like that to send that traffic to. So in this case, /images will go to the image server pool, /video will go to the video server pool. The thing to bear in mind about Azure Application Gateway is this is region specific. So if you have the requirement to use multi-regions across the Azure globe, then you wouldn't be able to use an Azure Application Gateway for that. You'd have to use the alternative, which if we move on to the next slide, is Azure Front Door. So similar to Application Gateway, this is a HTTP-based service. And you can see in the example there, it's also using some URL-based rules to send traffic to a particular server pool. You could actually still use an application gateway in front of those servers. If you look at the region 1 and region 2 deployments there is a bunch of VMs there. You could use an application gateway in front of those as well, but you'd have to have one at each site. If you wanted to do application gateway based load balancing at those sites, you wouldn't be able to span multiple regions with that. So the combination of Azure Front Door there and the application gateway would probably give you the best functionality in this particular example there. Azure Front Door is a global service. Essentially, it will sit sort of in front of the Azure cloud, so you can access any of your regions that you've got deployments within. And you've also got the failover option as well there. So it uses health probes to determine whether a particular region services are online or not. And you would fail over to the alternative one if those services fail for whatever reason. So looking more generically at layer 4 load balancing, so you've got the Azure load balancer here, which is able to load balance all UDP and TCP protocols, so it doesn't have to be HTTP or HTTPS as per Azure Front Door and Application Gateway. And yeah, as you'd expect, this has been around for quite a long time. It uses a standard sort of load balancing technique to determine whether backend nodes are alive or not, and if they're not, it will automatically remove them from the pool. You use a health probe setup, usually connecting on a specific port or looking for a particular response from those backend nodes, and if it doesn't get that response, it can automatically remove those from load for you. This is zone redundant, so it has the concept of has the understanding of availability zones within regions in Azure. So UK South, for example, which has 3 availability zones, you can span your virtual machines and your Azure Load Balancer across multiple zones to give you a little bit of resilience, but it's not a global product in this particular case. You need to hook it in with something like Azure Traffic Manager, which is the sort of equivalent, the global equivalent of the regional product that we just talked about. So this is a slightly different service in that it's a DNS-based service, so it doesn't actually process the traffic in any way. It will just give an appropriate DNS redirection response to the end user to send them to a particular place. So you can see in the diagram there, we've got a user that's based in Europe that's connecting into a traffic manager presented URL, and the traffic manager is responding with a DNS redirect to the North Europe Cloud App endpoint, because that is the most relevant to that particular user's IP address. If they've got a US-based IP address, then it would have responded with the US DNS response. So it doesn't actually traverse, it doesn't actually process the traffic in any way. It's a DNS-based service in this case. And again, this is a global one. Obviously, the nature of it can respond to any request from anywhere in the world and redirect you to the most relevant place. So you get the best user response from those types of services when you use them. So we've talked about 4 different load balancing options there, and it can be quite complicated to understand which one is the right one to use. This diagram kind of visualizes that a little bit. I'm going to have a little look in the portal as well in a second, just so you can get your head around exactly what that looks like. But it asks some fundamental questions initially, so you can determine which is the right product. So a web application, is it a web application that is internet facing? And if it is, then you're immediately ruling out things like your Azure Load Balancer, and your Traffic Manager if it's a specific HTTPS application. So you're then looking at the application gateway and the Azure front door applications options as the relevant options for you. And then it asks some other questions. Do you like to do SSL offloading for that particular application? Does it need to be multi-region? That kind of thing. And as you filter through those questions, you will end up with an appropriate response to what is the correct solution for you to use. And as I mentioned earlier, that could be a combination of more than one. And Azure have also made that real easy for you in the portal as well. So if I search for load balancing, you can see I've got an option to help me choose here. So if I click on that, you can see this is exactly the same questions that we've just seen in the diagram there. It's asking us exactly the same thing. So yes, I'm just going to run through these just as some examples. I'm going to say yes, it's HTTPS, and yes, it's internet facing. I definitely need it in multi-regions, and I would absolutely like some acceleration and SSL offloading. Because I've said yes to all those things, it's recommending Azure Front Door and Application Gateway. If I go back to the beginning, it's not a HTTPS application. I'm already down to a load balancer or a traffic manager. It's definitely internet facing. I'm going to say yes, it's in multi-regions, and it's saying, okay, these are the 2 options that you should go with. Use a DNS-based traffic load balancer to start with, and then use layer 4 load balancing at your regional levels to determine what happens to the traffic once it gets to that point. Again, just quickly returning to the slides. Yeah, we've just done that load balancer side. So now I'm going to talk a little bit about the connectivity to on-premise or from on-premise, as it may well be. So, I mean, with a cloud-first approach, everybody is trying to move services to Azure as quickly and as efficiently as they can to get the most out of the services that you can get within Azure. But there's always going to be the odd service that sits on premise that you can't get rid of or has some sort of localized presence requirement. Things like file servers or print servers and stuff like that. There are Azure equivalents for those things now, but there still might be legacy reasons why you need to keep those on premise. So Azure obviously give you a multitude of connectivity options into their environment to be able to use services in Azure. The sort of starting point is a point-to-site VPN. So you create a VPN gateway in the environment and set that up as a point-to-site VPN gateway, and that will allow you to download the configuration, which we can install on end user machines to be able to connect up to Azure. It can use the native Windows VPN client to be able to connect, and the configuration, as I say, is downloaded from Azure and added to users' devices to allow them to connect. We tend to find, though, that most people already have a level of connection into their corporate network, so the point-to-site VPN probably isn't the way to go. which is where the site-to-site VPN comes in. And this works in exactly the same way as another site-to-site VPN that you may have between on-premise firewalls. In this case, you just create a termination device in Azure that you terminate that site-to-site VPN to. And it uses your internet breakout to be able to connect those services. And you can see the example there is an IPsec VPN tunnel that's generated across those two links. All the routing set up automatically for you via the VPN gateway as well, so you don't need to do any of that. It's all available there to use. There are a number of different SKUs as well. So these are, you can use region-specific ones. You can use zone redundant ones as well. Each of them has a level of throughput that's capable through those, and each of them has a level of resilience built into them as well. And obviously, the further down the SKUs that you go, the more expensive that becomes. There are throughput charges as well, so you need to make sure that you're aware, or at least have an idea of how much traffic is going to be traversing that VPN, so that you can determine which is the right SKU for you. There will naturally probably be a breakout point as well, where the things like an ExpressRoute, which is sort of the next level, becomes the more cost-effective approach. If you're sending a lot of traffic over the VPN, for example, or you're saturating your internet links because of all the traffic that's going over that, then an ExpressRoute is a good alternative, because that will give you a dedicated WAN link effectively in Azure. And you usually use some kind of partner to be able to facilitate that as well, a network provider, which would provide connectivity into the Microsoft Edge network from their partner connection, and they provide you with that last mile connectivity from your network into the partner, which then hooks you directly into Azure. There's a couple of options available with the ExpressRoute as well, so you can use ExpressRoute Local, which is specific to that region that you are deploying your services into. If you want to use just a standard or premium ExpressRoute, then that gives you access to the whole of the Azure backbone network once you've terminated into Azure. There's a couple of bandwidth options as well available, so they start at 50 meg and they go right the way up to 10 gig. And you can also, a couple of options with throughput, you can pay on a per gigabit for transfer rates, or you can select the unlimited options. Again, there will be a cut-off point where the unlimited option is the more cost-effective approach, because you're sending a lot of traffic over that. And again, that all depends on the speed and things like that for the cost of those. You tend to find that people, when they're first starting to deploy into Azure, the site-to-site VPN is the right way to go. But then as things evolve and as more and more services are traversing that site-to-site link, ExpressRoute becomes the more viable option at that point. Okay, so those are the sort of fundamentals I wanted to talk about today. There are obviously lots more things available, as we saw on that first slide right at the beginning. So hopefully I'll do another session just to talk through some of those, but hopefully that was useful. Thank you very much.